Braizon Therapeutics has a technology for to deliver the drug to the brain. Brain has the biological barrier to protect the brain itself. It makes the development of the drug for the CNS disease is difficult. We have the solution. Here is the the asset. The brain has a biological the barrier. It's called the blood-brain barrier. It's that this barrier can not allow to any molecule to the brain. However, it takes an important molecule which brain needs. That is the mechanism they have. As we said, the current approach is very, very difficult to get into the drug to the brain. On the other hand, the central nervous system drug market is growing so much because of the aging population, and the patients of the CNS disease like the dementia, Alzheimer, the Parkinson, ALS, it's increasing. So this, the unmet needs plus expand the patient population makes the market potential is huge. Here is our technologies. We have the technology to make the small nanoparticles. Here is nanoparticles. It's nanoparticles surrounded by glucose. And then when we administer this the nanoparticles, we fasting, and then this the nanoparticles attached to the glucose transporter 1. We use the glucose transporter 1, the mechanism in BBB. Blood is necessarily taking the glucose. That is very important mechanism we have. Here is the result. This is our my cell that size of 30 nanometers. And also here you can see we achieved 6% of the accumulation rate in the brain by this the administration method. You can see, of course, the glucose transporter, any the drug, any organ has that the molecule. However, by fasting and eating the glucose, that means the glycemic control, only the brain has a stimulation of the my cell. It seems this our technology is very brain specific the delivery. Here is the animation. You can understand what that when we make that the mind cell inside the drug inside of the mind cell and surrounded by the glucose. And then after the fasting the mind cell was administered via IV, and the mind cell go to the brain and then take the meal, and then you can provide the glucose to the brain. And at that time, the mind cell attached to the GLUT1 and the glucose coming to the brain. And then, the endocytosis was occurred, and followed by, the transcytosis. My cell moved to the inside of the cell and moved to the abdominal side, that means brain side. And then it is released from the GLUT1 and moved to the empty cell in brain. And the cell is uptaked this my cell. And my cell inside the cell, my cell was destroyed, and then the drug is released. Here is the comparison of the other technologies. Most of the company also use the active transporter system in brain, but our the technology achieved the most highest delivery rate. And also using the mindset, you can put any molecule like the nucleic acid medicine or antibodies and a small molecule. That is our advantage. Anyhow, thank you for listening. And our organization is, we have a headquarters in Tokyo and R&D in Japan, located in Kawasaki, Kanagawa Prefecture, and we will open the US operation at Boston. Thank you very much.